In January 1610, Italian astronomer Galileo Galilei pointed his telescope at Jupiter and observed four small objects orbiting the planet. These moons, Io, Europa, Ganymede, and Callisto, later known as the Galilean moons, were the first celestial bodies discovered to be orbiting something other than Earth. This directly challenged a widely accepted geocentric model Earth-centered universe and supported Copernican heliocentrism. Galileo's discovery played a crucial role in the scientific revolution and reshaped humanity's understanding of the solar system. In 1785, William Herschel, an English astronomer, made the first systematic attempt to map the Milky Way. By counting stars in different regions of sky, he concluded that the galaxy had a flattened disc-like shape. His study suggested that the sun was near the center of this structure, a misconception later corrected by modern astronomy. Despite its inaccuracies, Herschel's work laid the foundation for understanding the structure of our galaxy and inspired future astronomers to explore its vastness. Neptune's existence was predicted mathematically before it was observed. Urbain Le Verrier, a French mathematician, noticed discrepancies in Uranus' orbit and theorized the presence of an unknown planet influencing it. His calculations led Johann Galle and Heinrich d'Arrest to observe Neptune on September 23, 1846, confirming its existence. This was the first time a planet was discovered using mathematics rather than direct observation, demonstrating the power of scientific prediction and further expanding our knowledge of the solar system. In 1915, Albert Einstein proposed a theory of general relativity, revolutionizing physics. Unlike Newton's view of gravity as a force, Einstein suggested that mass and energy curve space-time, affecting the motion of objects. This theory was confirmed in 1919 when Arthur Eddington observed light bending around the sun during a solar eclipse, proving Einstein's predictions. General relativity not only explained the motion of planets, but also became fundamental in understanding black holes, gravitational waves, and expansion of the universe. Pluto was discovered in 1930 by Clyde Tombaugh, an American astronomer working at Lowell Observatory. It was initially classified as the ninth planet of the solar system. However, later discoveries of similar-sized objects in the Kuiper Belt led to its reclassification as a dwarf planet in 2006. Pluto remains an object of fascination, with the New Horizons spacecraft's flyby in 2015 revealing its icy mountains, vast plains, and thin atmosphere, proving it is far more complex than once thought. On October 4, 1957, the Soviet Union launched Sputnik 1, the first human-made satellite, marking the beginning of the space age. The small spherical satellite emitted radio pulses detectable on Earth, sparking global excitement and fear, especially in the United States, leading to the space race. Sputnik's success prompted the U.S. to accelerate its space program, eventually leading to creation of NASA and setting the stage for human space exploration. On April 12, 1961, Soviet cosmonaut Yuri Gagarin became the first human in space aboard Vostok 1. His mission lasted 108 minutes, completing one orbit around Earth. As he re-entered Earth's atmosphere, Gagarin ejected from his capsule and parachuted to safety. His historic flight marked a significant victory for the Soviet space program and intensified the space race. Gagarin became a global hero and a symbol of human exploration beyond Earth. On July 20th, 1969, Neil Armstrong and Buzz Aldrin became the first humans to walk on the moon, while Michael Collins remained in orbit. Armstrong's words, "That's one small step for man, one giant leap for mankind," symbolize the culmination of NASA's Apollo program. The mission proved that humanity could venture beyond Earth, fulfilling President Kennedy's 1961 challenge to land on the moon before the decade's end. Apollo 11 remains one of history's greatest technological achievements. In 1965, scientists Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background, CMB, radiation while working at Bell Labs. They were trying to eliminate a persistent noise from their radio telescope when they realized it was coming from all directions in the sky. This faint radiation was a leftover heat from the Big Bang, providing direct evidence that the universe had a hot, dense origin. Their discovery confirmed the Big Bang Theory and helped establish modern cosmology. Launched in 1977, Voyager 1 was initially designed to explore Jupiter and Saturn, capturing iconic images like Saturn's rings and Jupiter's Great Red Spot. As it continued beyond the planets, it sent back valuable data on the heliosphere, the sun's influence in space. On August 25, 2012, Voyager 1 became the first human-made object to enter interstellar space, leaving the solar system's boundary. It carries a golden record, a time capsule with Earth sounds and images, in case it is ever found by extraterrestrials. Before 1992, scientists only knew of planets in our solar system, but astronomers Alexander Woolsey and Dale Frail changed that when they discovered exoplanets orbiting a pulsar, PSR B1257 plus 12. This confirmed that planets exist beyond our solar system. In 1995, the first exoplanet orbiting a sun-like star, 51 Pegasi b, was found, proving that planets could exist in diverse conditions. Since then, thousands of exoplanets have been discovered, some in a habitable zone, raising the possibility of extraterrestrial life. NASA launched the twin rovers Spirit and Opportunity in 2003 to study Mars' surface. Landing in 2004, they found strong evidence that liquid water once existed on Mars, increasing speculation that life may have existed. Spirit's mission ended in 2010, but Opportunity continued for 15 years, far beyond its planned 90-day mission, covering over 45 kilometers. The data they collected paved the way for future Mars missions like Curiosity and Perseverance, which are actively searching for past microbial life. For decades, black holes were only theoretical, as no telescope could directly image them. In April 2019, the Event Horizon Telescope EHT captured the first ever image of a black hole in the Messier 87 galaxy. This image, showing a glowing ring of hot gas around a dark core, confirmed Einstein's general relativity predictions. The black hole's event horizon, the point beyond which nothing can escape, was observed, marking a historic breakthrough in astrophysics and furthering our understanding of the universe's most extreme objects. In 1995, NASA's Hubble Space Telescope took an unprecedented image known as the Hubble Deep Field. Scientists pointed Hubble at a seemingly empty region of the sky for 10 days, and the result was stunning. Thousands of ancient galaxies were revealed, some dating back to the early universe. This changed our understanding of galactic evolution, showing that the universe was filled with galaxies even in the deepest voids of space. Later deep field images provided insights into how the first galaxies formed after the Big Bang. On September 14, 2015, scientists at LIGO, Laser Interferometer Gravitational Wave Observatory, detected gravitational waves for the first time, confirming Einstein's 1915 prediction. These waves were produced by the collision of two black holes, sending ripples through space-time. Gravitational waves allow astronomers to study the universe in an entirely new way, detecting cataclysmic cosmic events that would otherwise be invisible. Since then, multiple detections have revealed the existence of black hole mergers and neutron star collisions, opening a new era in astronomy. In 2009, NASA's LaCrosse Lunar Crater Observation and Sensing Satellite confirmed the presence of water ice in permanently shadowed craters at the moon's poles. The spacecraft deliberately crashed into Cabeus crater, kicking up a plume of debris that contained frozen water. This discovery revolutionized future lunar exploration, as water on the moon could be used for drinking, oxygen production, and rocket fuel, making long-term human colonization of the moon more feasible. The European Space Agency's Planck satellite, launched in 2009, created the most detailed map of the cosmic microwave background CMB in 2013. This radiation, left over from the Big Bang, is like a baby picture of the universe. Planck's data refined our understanding of the universe's age, 13.8 billion years, and composition, confirming that it is made of dark matter, dark energy, and ordinary matter. This map became one of the most important tools in cosmology, shaping modern theories about the universe's evolution. On May 30th, 2020, SpaceX made history by launching the first commercially built and operated spacecraft, Crew Dragon, with astronauts aboard. This mission, called Demo 2, carried Doug Hurley and Bob Behnken to the International Space Station, ISS, marking the first crewed launch from U.S. soil since the Space Shuttle retired in 2011. This event paved the way for private spaceflight, opening the door for space tourism, commercial lunar missions, and future Mars exploration. In October 2017, astronomers discovered an interstellar object passing through our solar system, named Oumuamua. This mysterious, elongated object was unlike anything seen before. It was moving too fast to be from our solar system and had unusual acceleration, leading some to speculate that it might be an alien probe. Scientists eventually concluded it was likely a natural object, possibly a fragment from another planetary system, but its exact origin remains unknown. It was the first confirmed interstellar visitor, proving other star systems eject debris into space. Launched in December 2021, NASA's James Webb Space Telescope, JWST, released its first full-color images on July 12, 2022. These images revealed the deepest, most detailed view of the universe ever captured, showing distant galaxies, exoplanets, and star-forming regions. Unlike Hubble, JWST uses infrared light, allowing it to see through cosmic dust and peer back to the very first galaxies formed after the Big Bang. Its discoveries are expected to redefine astronomy, helping us understand the formation of planets, stars, and galaxies.